Boom! I just got full remote command line access to this machine. Look at this. I can list all directories, access system files, run commands freely. And the crazy part? I only used Nmap for this. Nmap, or Network Mapper, is used to discover live hosts, open ports, running services, and even operating systems on a network. And today, I'll show you the exact steps to turn simple scanning logic into full system compromise.
So I began by scanning the entire subnet using sudo nmap sn 192.168.0.0/24. The key part of this command is sn. This tells Nmap not to scan ports, but simply to check which hosts are alive. I just want to know who's present. The /24 part defines the size of the network. In practical terms, that means Nmap will check every address in my network. After running the scan, I saw multiple IP addresses responding. This IP was clearly my Wi-Fi router, and this IP was my own Kali machine. Once I eliminated those known devices, .106 IP stood out as a potential target. Hacking often starts with simple logic. Remove what you recognize, and what remains becomes interesting. So now, let's dig deep in this suspicious IP. Why I added PS 80, 21, 22, and 23. By default, -SN mainly relies on ping. The problem is that many systems block ping traffic through their firewall. That means a host could actually be online, but appear down because it ignores ping requests. Once I confirmed the host was up, I moved on to deeper enumeration. First, I used the -SS option, which performs a stealth scan. This scan works by not completing the full TCP handshake. Instead, it sends a SYN packet and waits for a SYN-ACK response. If it receives that response, the port is considered open. It's faster and slightly less noisy than a full connection scan. After identifying open ports, I used -S-V. This is version detection. Now I don't just want to know which port is open. I want to know its version too. If port 21 is open, what FTP server is running? What version? Vulnerabilities are often version specific, so this step gives context to the open ports. Then I used -O for operating system detection. At this stage, I had a complete reconnaissance. I knew the host was alive, which ports were open, what services were running, their versions, and the likely operating system. From here, there are two common approaches. One option is manual research. For example, if I discover that the FTP service is running a specific version, I can search online for known vulnerabilities associated with that version. The other approach is using Nmap's built-in vulnerability scripts with sudo nmap --script vuln and IP. This runs a collection of scripts that check detected services against known vulnerabilities. It doesn't automatically exploit the system, but it helps identify potential weaknesses based on known CVEs. After the scan is complete, which will take time, we found that this FTP service had a vulnerable version, which can potentially give us a root user CMD. I opened a new terminal and launched Metasploit using MSF console. When Metasploit loads, you're inside an interactive framework where you can search, configure, and launch exploits. The first thing I did was search for the CVE related to that FTP version. Using the search command, I looked up the vulnerability identifier. And there it was, the exploit module that matches the FTP vulnerability we discovered during reconnaissance. Once I found the correct module, I loaded it using the use command. That tells Metasploit this is the exploit we're going to configure and run. Now every exploit module has parameters, so I ran the options command to see what needs to be configured. In this case, most of the settings were already pre-configured. The only required field was rhosts. Rhosts simply means the victim machine's IP address, so I set it to .106. After setting that, I ran options again. It's just rechecking your configuration before launching an exploit. Everything looked correct. So I executed the exploit using exploit. At first, it looked like nothing happened, but then Metasploit displayed a message saying that a session was created and then closed. This can be confusing for beginners. Did it fail? Did it work? Instead of assuming anything, I checked active sessions using sessions, and there it was. A session was actually running. Now, to interact with that session, I used sessions-i1. The moment I entered that command, boom, we had a remote shell, a root command line interface on the target system. And just like that, the entire journey transformed from an Nmap network scan to full exploitation.